Hello, Mr. Ryan. Okay. Okay, so today we are going to talk a very interesting problem called the visible blocks. Okay, so let's say we have n
really
blocks. Yeah, we have n
It's not
blocks.
really interesting.
N blocks. Come on, come on. No. Okay. We have n blocks, and the size is 1 to n. Okay, so look, this is one block. Hey, you know the number of blocks, yeah? 1, 2,
Number block.
3. Okay, come on. So n blocks.
This is the block.
Okay. 4, okay? Okay, so let's say we have 4 blocks, n equals 4. And then the block type is 1, 2, 3, 4. Okay, so if okay, Eric or Ryan, you know, yeah, standing on the left, look to the right. How many blocks can you see? How many blocks can you see? Ryan, Eric, how many blocks can you see?
All of them.
All of them, 4. Right? Yeah? Exactly. So how about this? How about this? So if you here to the right, how many blocks can you see?
I could see 1, 2, 3,
No.
4. 1.
1, yeah, exactly. Yeah. Okay, so the question is that I have n blocks, right? And I'm standing on the left. Ryan, come on. And I want to see exactly k blocks, right? So how many ways can we arrange the blocks? Do you get it? For example, if k equals 1, okay, if k, let's say if k equals n equals k. So for example, I have n blocks, I want to see exactly k blocks. How many ways can we arrange the box?
Always the tallest one at
No.
wait, I don't really get it.
Okay, so look, you are getting there, right? So I have 4 blocks, and I want to see exactly 4 blocks. How many ways I can put it? Right? So look at 1, 2, 3. Only 1, right?
Yeah.
Exactly, because you can't. That's the only order. If we don't have this order, some blocks will be invisible, will be blocking others, right? Yeah, that's only 1, right? Okay, that's very good. So when n equals k, then we should return 1 because there's only 1, right? From the smallest to the biggest, alright? Okay. How about k equals 1? So I want to see exactly 1 block.
So always the tallest block
At the front, well done, very well done. So always the tallest block. But how about these? It doesn't matter, right?
Yeah, it doesn't matter.
Okay, so how many blocks are there?
3.
Yeah, there are n blocks overall, and I have 1 block, the tallest, in the front. So how many blocks here?
N minus 1.
N minus 1. Okay. So far, it doesn't matter. You say it doesn't matter. So n minus 1 blocks doesn't matter. How many permutations? When we talk about how many orders, I mean, what times? Yeah, you cannot do it. Look, three blocks. How many permutation? How many ways?
6.
Exactly. How? The first block we have 3 choice. The second block we have 2 choice. The third one we have 1 choice. What's this?
6.
Yeah, I know. What's this?
Factorial.
Well done. So n minus 1 factorial. Yeah. Exactly. Yeah. So when k equal 1, we return n minus 1 factorial. Right? Exactly. Okay, now tricky part is here. Yeah? This is the difficult part. If you don't get it, that's fine. Right? But that's very good if you get you can already get these 2 parts. That's very nice, okay? Yeah? Okay, so now these 2 are base cases, very easy, yeah? Okay. So now how about n is not equal k and k all is not equal 1? So look. Yeah. So how about that? I have n blocks, right? And then how about if I put the smallest one in the front? Okay, let's say I want to put the smallest one in the front, right? Yeah. So I can always see it, right? Because it's smallest in the front, right? Yeah. Yeah, I can see it. So let's say fnk is the number of ways that I need to place n blocks, and I want to see the k visible blocks, right? Yeah. Ryan, got it? So now I put the 1 block at the beginning, the smallest, right? And how many blocks left? How many blocks left? I put one block in the front. How many blocks left?
-1.
And -1. We're done. Right? And I can see one blocks. How many more blocks I need to see? I need to make it C. Also -1, right? So that's K -1, right? Yeah? When we put the smallest, why can we do this K -1? Because this is the smallest, right? If this is smallest, what happened? I can see all the blocks on the right hand side, right? So let's F n -1 K -1. Okay, that's one part. If I don't put the smallest on the left, okay, this is the tricky part. If I don't put the smallest on the left, I can put it in n-1 position, right? I can put it in n-1 position, right? Yeah, but I still need to see K blocks, right? Because this block is invisible, right? Because it's the smallest. So it's the smallest, it means that it's invisible. The leftmost block blocks it, right? So it's Fn-1 K. Okay? Yeah? So how many ways we can do this? I was just saying I can place the block in n-1 position. So we can just times it. Right? Yeah? So how many ways for these two? We do it, add it together.
Yeah.
Okay? So do you get it, Ryan? Let me repeat it, okay? Let me repeat it. This is a bit tricky part, okay? Okay, let me repeat it. Come on. Can you stand here for a while? Okay, listen one more time. This is very interesting, okay? Ryan, you got it? N equals K, there's only one way, right? From the smallest to biggest. K equals 1. What does it mean? The tallest on the left, right? And what's on the right doesn't matter. And there are n-1 blocks here. So it doesn't matter. What does it mean? It doesn't matter. We can do this full permutation on n-1 block. That gives us n-1 factorial. Okay, so now for the n blocks, we want to see K blocks. Yeah? Or total n blocks, we want to see K blocks. Everybody? Why are you doing what you're doing? Yeah? N blocks, I want to see K blocks. What happened? If I put the smallest on the left, I can see it, right? So if I put the smallest on the left, I can see it. So these how many ways I can do it? That's Fn-1 K -1, right? Because I already put one blocks here. So I have n-1 blocks left, and I have K -1 blocks left to see, right? But if I don't put it on the left, I put it somewhere from the right on the right hand side because it's the smallest block. It's invisible. Am I right? If it's invisible. So what does it mean? If it's invisible, then we still have K blocks left to see, and we have n-1 blocks. But how many ways can we do this? n-1 times it. Why is that? Because we can place this smallest block on n-1 position. Got it? So now we can implement this. Okay. We have this equation. So how can we implement it? Anybody? If I already have this defined Fn-K equals, okay, let's say n-1 factorial when K is 1, or what? 1 when K is n, and otherwise what? Fn-1 K -1 plus n-1 times Fn-1 K, right? So otherwise, so we have defined this. How can we implement this? Look, what's this? Fn-K, Fn-1, Fn-1, K -1. What do we do with this? How do we implement this? If you look at this, there's F. How do we implement this? Yeah, what do we call it?
Recursion.
Well done, recursion. Wow, you're on fire today. Recursion, yeah. Define.
Burning. You're not burning.
I know that's a
See, how
metaphor.
is burning?
That's a metaphor saying, okay, you're so good today. Okay.
Wait, why is burning good?
Okay, Fn-K, right? Okay, and that we have to also give if it's 0 when n is smaller than K, right? Does it make sense? when n is smaller than k, what happens? What value should we get? If we have n blocks, we want to see k blocks. K is bigger than n. How many ways can we do it?
0.
Exactly. That's common sense, yeah? We have 3 blocks, we want to see 4 blocks. How is it possible? Yeah? 0 here. So if n smaller than k, return 0.
Oh, you broke the thingy.
Okay? So if k is 1,
Dusty.
return n minus 1 factorial. We talk about factorial, yeah? We can use the math factorial thing. Yeah, factorial. K n minus 1. If n equals k, we return 1 exactly. Otherwise, we return f n minus 1 k minus 1 plus n minus 1 times f n minus 1 k. Okay, so that's the recursion. Look, when f and k, right? N is always decrementing by 1, right? But k sometimes decrement, sometimes not. So what does it mean? Look, if n is always decrementing 1, right? And n is smaller, is bigger than n. N is bigger than k, right? So what does it mean? Either k reaches 1 first, or n reaches k first. So in that case, we define these two terminal conditions. That could be sufficient. That's sufficient, yeah? Because n is always decrementing 1. Look, okay, so n is bigger than k, right? N is always decrementing 1. But k sometimes not decrementing. So it means that k will reach 1 first, or n will reach k first, right? Yeah, so we have these two. So Ryan, do you understand this? Do you understand this? Do you understand this? And do you understand this? Anyway, do you understand these 4 bits? This. The first 3 you understand, yeah? Obviously, yeah? How about this one?
Guess I.
Yeah, okay, let me repeat this, okay? This is a little bit difficult to understand, okay? But don't worry, okay?
It says it's hard.
Yeah, I know. That's why I'm repeating one more time, okay? Okay, everyone, for the last time, come on. For the last time. Yeah? So, f and k means that I have n blocks and I want to see k blocks, right? And let's try to place the smallest block on the left. Yeah? So what does it mean? If I place the smallest block on the left, can I see it? Can I see it?
Yeah.
Yeah, obviously I put the smallest on the left. I put anything on the left, I can see it, right? So if I put the smallest on the left, I have n minus 1 blocks, right? Because I already used 1 block. And how many blocks left to see? K minus 1, right? Because I look, f and k, I want to place n blocks and see k blocks. I put the smallest on the left. I have n minus 1 block, and I have k minus 1 blocks to see. Okay, that's this part. How about this part? If I don't put it on the leftmost, I can put it on n minus 1 position, right? Because there are total n blocks. If I put the smallest block on the right, what does this mean? Can I see it?
No.
No, obviously, because look, the smallest block, I can put it on the right. I can put it in n minus 1 position, but it's the smallest. What does it mean? It can't be seen, right? You will be definitely blocked by the leftmost block, right? So I have still n minus 1 blocks to use, and I still need to see k blocks. But how many blocks? As I said, I have n minus 1 positions to put the smallest block. So I need to times this by n minus 1. Got it? That's where we come from, right? This is mathematics. Actually, this is not coding. This is mathematics. Yeah? Mathematical equation. The most important thing today is this mathematical equation. How are we getting it? How are we solving this? We're using computer. This is just implementation of this mathematics. Look, you can figure out from this Python code. It's easy, right? Yeah? The Python code. No skills. Yeah? We can put a cache, yeah? We can put a cache to remember the values we have seen, yeah? But I doubt this will be useful because the n will be based on n minus 1, k minus 1, k, yeah? Maybe, yeah. So it's not reusing it, right? It's not, do we reuse the intermediate results?
Maybe do.
That's a good question. Let's try. Okay. Let's say f n minus 1 k minus 1. That will be based on what? No, fnk. Fnk will be based on n minus 1 k minus 1 and n minus 1 k, right? Okay, and then here n minus 1 k minus 1 will be based on n minus 2 k minus 2 and n minus 2 k minus 1. Yeah, n minus 1 k will be based on n minus 2 k minus 1 n minus 2 k, right? So do we see any repeated value? Here, look, we see this repeated. We have seen this repeated. N minus 2 k minus 1, right? N minus 2 k minus 1. This is like a binary tree. On the right, the binary tree, the left tree, k doesn't k change by 1, decrement by 1. On the right tree, k not changing. So look, n minus 1 k minus 1. This will be n minus 2 k minus 1. Okay, so look, we have these overlapping subproblems. So it means that we can put a cache here to save, to speed up, right? So in that case, the maximum stage we are calculating is n times k, right? Because there n will be from 1 to n minus 1, k will be from 0 to from 1 to k minus 1, so n times k. Okay, so that's the very important thing today. Okay, it looks like similar to Fibonacci number, right? Yeah. Okay, that's it. Bye bye.
Bye.